Hello everyone, this is Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 311001. In our previous session of this particular session, we deal with chapter number 3, which is metals, alloys and corrosion. In our chapter number 3, we have studied about what is the metal actually, how many types of physical properties do the metal actually possess. Then we have taken a look on the types of alloys. What is an alloy and how many types of alloys are actually there. Then we have observed certain kinds of examples of alloy, like we have seen the ferrous alloy, we have seen the non-ferrous alloy, and along with it we have observed its applications, their compositions, their properties, etc. Now, from this particular part, we will start with corrosion. What is the corrosion is? So the surface of all the metals begin to decay more or less rapidly when exposed to atmospheric gases, water or other reactive liquid medium. They react tremendously. Some reacts fast, some reacts late, but they react in some way. Now, because of this reaction, what happens is the decay. So the process of decay of the metal by environmental attack is known as corrosion. The degradation of metal, decomposition of metal or decay of metal. All these three verbs moves together. They all are known as corrosion. In the image, as you can see, the red part shows rusting of the part. That rusting is the corrosion. By age or by time, as years together or years moves, along with it, this rusting or this corrosion came into picture. Okay? Now, let's take a look on causes of corrosion. Which are the reasons why the corrosion is actually caused? So, the metals actually exist in the nature in the form of their minerals, in ores and in the combined forms as oxides, sulfides, nitrites, etc. After that, extraction of the metal is done to convert in pure metals. So what happened? The isolated pure metals are regarded as excited states, then their corresponding ores. So metals have natural tendency to go back to their combined states or their mineral or their core state. So what happened? Now when this metal is exposed to the atmospheric gases or moisture or chemicals or liquids and the metal surface reacts, corrosion occurs. Understood it properly. We have an ore is converted into pure metal, which is excited state. it gets exposed to the gases, to the atmosphere, to the particular kind of chemical or gases, and the corrosion starts. We have to make sure that the particular metal should be coated in order to prevent it. That we will see in our next sessions. But here, this is the reason that why corrosion generally occurs. Now, what are the effects or what are the disadvantages of corrosion? So let's take a look on it. It creates wastage of metal in the form of its compounds. The valuable metallic properties like conductivity, malleability, ductility are lost due to corrosion. The lifespan and efficiency of metallic parts of machinery and fabrications is reduced. So in general, when corrosion occurs, at that time corrosion destroys almost every property of the metal. It destroys its looks, it destroys its properties, it destroys its characteristics, and at last it creates loss of efficiency of that metal. Actually, that means why we are using the metal, that reason is totally destroyed when corrosion occurs. So we have to make sure that we have to prevent a metal from corrosion in any condition. Okay? Now, let's move on to our next point and our main point, which is theories of corrosion. Theories of corrosion can be divided into two different parts, or I should say, corrosion can be divided into two parts. First part is wet corrosion, and second part is dry corrosion. So wet corrosion is also known as electrochemical corrosion, while the dry corrosion is known as chemical corrosion. We will take a look on wet corrosion and on dry corrosion one by one. We will see their mechanism, that how and why it is known as electrochemical corrosion and why dry corrosion is known as chemical corrosion. We will take a look on the mechanisms, that how and why such thing actually happen. Let's take a look on the first one, which is dry corrosion or chemical corrosion. So this type of corrosion occurs mainly through the direct chemical action of atmospheric gases like O2, like halogens, H2S, SO2, N2 or anhydrous inorganic liquids with the metal surface. Here there are three different types of chemical corrosions are there. First one is oxidation corrosion. Then second is corrosion due to other gases. Here what we have to take a look is, such kind of corrosion occurs due to gases, right? Due to atmospheric gases. Now which gases are commonly present? So oxygen is widely present. Then we will have a corrosion due to other gases like H2S corrosion or H2S is present, which can cause corrosion. Nitrogen is also present in the atmosphere, which can further cause corrosion. So we will take a look on it one by one. Let's move to the first one, which is oxidation corrosion. Oxidation corrosion is generally carried out by the direct action of oxygen, whether at a low temperature or high temperatures, on metal in the absence of moisture. This generally happens because of the action of oxygen. Again, temperature doesn't matter, but it happens in absence of moisture. Okay? And alkali metals and alkaline earth metals are rapidly oxidized at low temperatures, while at higher temperatures all the metals get corroded. Let's take a look on oxidation corrosion here. As you can see in the image, we have M, that is our metal. When oxidation occurs, it converts itself into M2 plus 2 electrons are released. Now oxygen gets reducted. So oxygen plus 2 electrons get reduced, convert itself into 2 O raised to minus 2. What happened? This M and O2 mixes together. So metal reacts with oxygen and get converted into M plus 2 plus 2 O raised to minus 2. That is a metal oxide. So what happened here? That the metal converts itself into metal oxide form. So the corrosion starts here. Okay. Let's take a look on the image which I have shown you here. As you can see, there are two main parts. First is metal, right? This metal block. So here what you can see, that inward diffusion of oxide ions through the scale occurs. Scale is there. Here we are taking a look on boiler. We take it as a boiler wall. So through the scale. So oxygen gets in the contact with metal. Now other way, atmospheric oxygen can also be exposed to the metal. In both of this manner, both of this oxygen directly gets involved with the metal which is present there, which is in M raised to plus N form. There what happened? Formation of metal oxide at the point of meeting occurs, where M plus 2 and O raised to minus 2, both of them mixes together. There the formation of metal oxide occurs, right? So here it converts itself into metal oxide. This moves ahead. Again, this moves ahead and corrode the whole metal, right? This outward diffusion of metal ions to the scale generally happens. Now here what happened? The direction of electrons conduction is from the metal to the outer side, and metal oxide scale formed by the direct reaction of metal and oxygen ion. So in this manner, this whole thing mixes up together and this process becomes faster. And the whole block, starting the volume of metal block will be like this. And when it's corroded completely, at the corrosion, it will get again reduced and reduced and reduced. So loss of metal, loss of the money, loss of time and loss of the instrument occurs when the material gets corroded. And this is very common because oxygen is widely present in atmosphere. So it widely happened then. This way, the corrosion, specifically oxidation corrosion, creates the problem for any kind of metal. If it's iron, then it's very fast. If it's alloy, then it's very slow. We can convert a particular metal in such a manner that the less and less corrosion should be created. We have to create a coating on it so that we can prevent the metal block. Okay? This is all for this session. Next, we will see in our next session. Thank you so much, everyone.